Hi students, we're going to take a quick look at your assessment from Thursday the 3rd. This was the mini assessment over chapter 3.1. So we're going to walk through, open up your Desmos activity link that matches this quiz, and then we will walk through it. Remember, the best way to do this is to pause it, review, and then watch what I'm doing. So study. Come to office hours at 3:30, Monday through Wednesday, or Saturday at 11 to 12, and retake this quiz. So here we go. So let's get ready to do some math. All right, this first problem, remember, we are just expanding x to the 5th in the numerator, which is on top, and y to the 3rd in the denominator, that's on the bottom. So it needs to be a fraction. So you look here, we have x times x times x times x times x. That's expanded form of x to the 5th. And y times y times y, that's the expanded form of y to the 3rd. All right, now we have n to the 3rd times n to the 4th times n to the 5th. And so when we do this, remember, when we multiply the bases using that product rule we learned, we can add the exponents. So this is the same as saying n to 3 plus 4 plus 5, and you get n to the 12th. I saw some of you multiply, all right? But we're multiplying the bases, we add up the exponents. And we learned how to do that by writing out all the n's, like this. All right, and that'd be 12 of them. All right, question 3. Now pause this one, take a look, see if you got it right. Y to the 4th to the 3rd power is the same as saying I have y to the 4th 3 times. Or we can use that power rule that says we can multiply the exponents when we take a power to a power. So we end up with y to the 12th. All right, how'd you do? Here's question 4. This one was a little trickier for some of us. This is a quotient, right? So we have b to the 3rd over b to the 5th and c. So b to the 3rd, c to the 6th, b to the 5th, c to the 1st. And so remember, quotient rule says we can subtract our exponents. So we have 3 minus 5 and 6 minus 1. If there's no exponent, remember it's 1. And you get b to the negative 2nd, c to the 5th. This would be acceptable, but you could also write it c to the 5th over c to the 2nd. Or sorry, b to the 5th. I'm going to start that one over. You could also write it as c to the 5th over b to the 2nd. Remember, it's negative if it's in the numerator or positive if you move it down to the denominator. So either one of these two examples is correct. You can also expand them, and remember, use the power 1 to eliminate things that divide out to 1. Let's just check that out quick. So we'd have b times b times b times c times c times c times c times c times c. That's the numerator. And on the bottom we'd have b times b times b times b times b and c. That giant 1, right? We have 1, 1, 1, because b over b is 1, b over b is 1, b over b is 1, c over c is 1. We're left with 5 c's on the top and 2 b's on the bottom. Either way, we get c to the 5th over b to the 2nd. All right, here we have 12 m to the 5th over 6 m to the 5th. You might notice right away m to the 5th divided by m to the 5th, we can do the same power 1, right? That big 1 right there. And then you'd be left with 12 over 6, which is simply 2. If you didn't see that, you'd still divide 12 by 6, and you get 2. M to the 5th minus 5 is the same as saying 2 to the m to the 0. Well, I accepted this as an answer. M to the 0 is 1, so we'd have 2 times 1, which just brings us right back to 2. All right. let's finish this off. Now you have g to the 10th. The problem here is asking you to write g to the 10th write three different expressions that all equal g to the 10th. So using the product rule, you could have said like g to the 5th times g to the 5th, or g to the 2nd times g to the 8th. Notice both 5 plus 5 and 2 plus 8 equal 10. So when we multiply the bases, we add the exponents. To get to the g to the 10th with the product rule, or the power rule, we could have g to the 5th to the 2nd power, because 5 times 2 is 10. We could say g to the 10th times 1. We could say g to the 2nd times 5. A few possibilities there, right? But the power to the power, remember, you multiply. We could use the quotient rule as well. I could have g to the 20th over g to the 10th, because when we have that, we subtract the exponents in the quotient rule, and we get g to the 10th. But you could really do just about any combination as long as 12 minus 2 is 10, just as long as you have your exponents subtract to 10. So there's a couple of quick ways of looking at this. Study it. Come back to office hours, ask your questions. I'll walk through these slides as slow as possible. The goal is, can you learn something? All right. I don't want you to focus so much on the grades as much as I want you to focus on the learning. All right. See you soon.